All right, 3, 2, 1, here we go. I want to make sure that you guys feel good about this this assignment. So let's see how fast our board's going to work with us today. A little quicker than yesterday. All right. So it looks like the first problem is 2 root 75. Is that right?
Oh, yeah.
Okay, let's talk about this. Enough of the whistling, please. So that 2 is coming along for the right. And if anything comes outside of the radical, that 2 will multiply with it. Is that okay? That statement makes sense? So I'm not quite sure, but we can refer to our perfect squares. We know that we have these. So let's just utilize these the best we can. 81, 100, 121, 144. That should be all right. So let's glance at the list real quick. And if we see something right away, we'll go with it as a perfect square. If we don't, then we won't. Any of those times a number, can you give me 75? 25? That works. What about that? Is that okay? Make sense? And so we have to understand that the concept that takes place is really this. And what is that going to be? So that becomes 5. So I get 2 times 5 times root 3. And what's 2 times 5? 10. So we get 10 square root 3 or 10 root 3. Does that seem okay? And then the next one we have 3 root 8. 3 root 8. Okay? So can we break 8 down to one part of it being a perfect square? Which one? Yeah, 2 times 4. So this is going to be the same thing as this, which is the same thing as this. What does this become? 2. What happens with the 3? Multiply. Oh, boy, I'm making up stuff as I go along. Sorry. So 6 root 2. Seem okay? Well,
I need to get a new calculator.
No, the calculator might be right. It's just that when you plug it into your calculator, being that you have the radical 2 on there, that might have goofed things up in there. Then we get 11 times root 11 times root 11. Okay, which basically is the same thing as this. And if we're doing square root, we're looking for how many of a kind? 2 of a kind. So both of those come out. Nothing left inside. So what's my answer? 11. Good. Okay. Feel okay with those? Next one we come across is root 8 times root 14. Is that right? Okay, so now this is where it starts getting weird in my head. Okay, so I have to understand that this is the same thing as this. Is that okay so far? And again, I'm going to try and write all the steps down. Can you skip steps from time to time? Absolutely, but I'm just trying to show you the thought process. So what I want to do is I want to break 8 down. And I know that 8 is 2 times 2 times 2. Is that okay? And I'm going to break 14 down. And now 14 is 2 times 7. So how many of a kind am I looking for? 2 of a kind. So what comes outside with that? 2. And what comes outside with that? 2. So I have a 2 and a 2 both outside. So what's outside? 4. Because both those come out. This square root of this is 2. Square root of this is 2. So I get 4 outside and square root of 7 inside. So why didn't I do it the traditional way? Well, sometimes when I'm multiplying things together, it starts twisting around. And some of you might have said, well, I want to go 8 times 14. Good. You're going to get the same answer as us. Okay? We all right so far? Can I erase these? Okay. The next one, root 25x squared y 6.
They skipped one. It was 5 squared 10 times 3 15.
Times what?
It was like 5 squared 10 times 3
Oh.
squared 15.
There we go. Okay. So we skipped one accidentally. We'll get there. So that's the next one. What do we know about the 5 and 3? What's going to happen? They're going to be multiplied. And do they stay outside if I multiply them?
Yes.
Yeah. And then technically, I could multiply 10 and 15 together if I wanted to get 150, which would be all right. Or I could start doing this. I could say, well, I know that 10 breaks down to 2 times 5, and I know 15 breaks down to 3 times 5. What do you think? How many of a kind am I looking for? 2 of a kind. I'm looking for pairs. So I have this and this. So if I take the square root of that, I get a 5 that comes out. This 5 and this 15 do what? Multiply. So what's 5 times 15? 75. And then I have left inside this and this, so I'll multiply them back together. 75 root 6. Okay. Next problem is the root 25. Can't see it. X squared y to the 6. Is that right? Go there. Okay. Some of you might be able to say square root of 25 is 5. So this is going to come out with this being 5. Okay, so I'm going to get this, and I'm going to write this out. All right? All right, I'm looking for how many of a kind? 2 of a kind. So what comes out with this? X. What comes out with this? 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 Everything came out. Do I need to put a radical anymore? Nope. So I get 5x. How many y's came out? 3. Done. Done. Okay? All right. Root 20x to the 4th, is that right? Root 20. Whoa. Time out. Frozen. Yo! What do we get? What root 20 what? X4. Okay. Let's see. Can we break 20 down into a perfect square and some other number? What do you think?
I think we would do
4 and 5? 5, 4? I like it. And then 1, 2, 3, and 4. Okay. Square root of this is? 2. What's outside now? So 2x squared. What's inside? 5. Cool. What do you think? Let's see if I can make this work. Nope.
Maybe you have the eraser.
No, it's sometimes it'll work with the edge of your hand. Apparently not this board. Apparently. 8y to the 6th. That next one. Okay. Can I break 8 down to a perfect square times something else?
Yes.
Okay. What does it break down to? 4 and 2. And then Okay, so what's outside? 2. What's inside? Done. This is usually where you get the one kid going, isn't square root of 2 1 though? No. 1 times 1 is 1. This next one, root 50 y to the 7th? No?
It's 5 squared 18x3.
5 18x this? Got it? Okay. All right. That 5's coming along. Anything that comes out, what does the 5 do to it? Multiply? Okay. Can I break 18 down to a perfect square times another number?
Yes.
What does it break down to?
2 times 9.
Here you go. And then 1, 2, 3. Okay. What is that? 3. So what's outside? And then, what else is outside? What's left inside?
2.
Done.
Where'd you get the? Oh, I thought that was a 1.
Where'd the 5 go?
No, I said, how would you get the?
I got you, but I didn't know the question over here.
Oh,
Square root of 9 is 3, right? And then 3 times the 5 is 15. So that's a 3 that comes out. And then Reese, what'd you have? Are you
no,
okay?
I was just like, wait, where'd you get the y? But then I realized.
Gotcha. Sweet. All right. What's next? Can't see it anymore back there. What number are we on? Who? 10? Root 50 y7. This one? Right? All right. Can 50 be broken down? What does it break down to? 25 and 2. And then y to the 7th. What does that give me outside?
5.
And then, what does that give me outside? Y to the 3rd. What do I have left inside? 2 and a y. Done. Sweet. Number 11, we got root 72 x to the 3rd, y to the 4th. I don't know, anyone see 72 breaking down? 9 and 8? Okay, I like that. Is there anything bigger though? And this is where it starts getting weird because you want to stick with the 9 times 8.
36.
But then there's the 36 and the 2. And that's where a lot of kids will make an error. So that's where sometimes, as our numbers start to get a little bit larger, my opinion is it's best to start breaking it down. So you're like, oh, okay, 2 times 36 is 72. So I'd start with 2. And then you could say, well, 36, oh, it is a perfect square. If it wasn't a perfect square, break that down further. Like if it was 38, go, oh, okay, 2 and 19 or whatever. But being that this is going to work here and here, I think we're okay. And then I have this. And then y's. Cool. So where's the square root? Which perfect square?
36.
Okay, what's outside now? What's outside? What's outside? What's inside? 2x. Where did all the rest of the y's go? They all came out. We took the square root of them. So it undid it. All right, number 12. We have 7 square root 12x6 y4. Is 12 going to break down to a perfect square times another number?
Yes.
What's that 7 going to do outside? Multiply. So I have 3 times 4, and then I have now, I know some of you are sitting back there going, do we really have to write out all of those? If it helps you, yes. If you get the answer right without doing it, don't. If you keep getting the wrong answer because you're not writing them out, write it out. I'm going to waste so much lead. Don't worry, we're in America. We're in the land of waste. We have plenty.
That was an airborne noise.
Yeah, I got you. All right. What breaks down up there? 4. So what number's outside then? 14. Does everyone see where that came from?
Yes.
Okay. What's outside? X to the 3rd. Good. What's outside? What's inside? Done.
Wait,
Yo.
how did you get the 14 again?
Go ahead.
What's faster, this way or the tree?
Whatever way works best for you. I mean, if you see the tree factor, please, by all means, do it.
Oh, that's how I do it.
Cool. And are you getting the same answer as I?
Oh, okay. I think so.
Okay, cool.
Yes, I am.
No, if you feel comfortable doing it that way, please continue to do it that way, okay? It's like Mr. Summers sees it the way with the perfect square times the other, real quick. Not everyone sees it that way. And again, it's not because anything's wrong with somebody, it's just that there's different ways of thinking, and that's totally fine. Is that all right? Does that answer your question? Let's see. Number 13. This might be one of those problems that we should probably write all out. So 8 breaks down to 2 times 2 times 2, and then I got all these y's. And then I get 2 and then y. And this is where people are looking at it going, why can't I just have all the numbers together and all the letters together? Oh, you can. You could have this. 8. Did I make up some math rule that you didn't know about? Well, you probably remember back in the early days of elementary education of order doesn't matter how you multiply. So I just changed the order up, put everything together. Okay? What's outside with that?
2, sorry.
2. And then what outside with that? 4. What's outside with that? That? Y. Everything's outside now. What's inside? It's square root of 1, basically, which is just 1. So there's your answer. You have to do it my way? No. Again, I'm showing you a broken down method that some of you are going to grab onto. Others of you are just going to be ticked off that I'm showing you a longer way that's against your thought process. And I'm not trying to take away from your thought process. 14, can I erase? Okay. My gut tells me, let's do this. So 6 is 2 times 3, and then I have x, y, y. Then I have 3x, x, y, y. Let's put everything in numbers and letters together. Cool. What's outside numerically? What's left inside? Done. So guys and girls, I'm going to tell you this. I've taught calculus. Okay, I'm not trying to toot my own horn, but I've taught calculus. I've had students do problems like this in calculus and do unbelievable on the AP Calc exam. Okay? So don't look at this going, oh, people are going to make fun of me. You make it work the method that works for you. Okay? And don't let somebody tell you you shouldn't do it that way. It's wrong. Your thought process is your thought process, and that's a beautiful thing. Don't let someone tell you your thought process is incorrect. Now, if you're getting the wrong answer, then your thought process isn't going through correctly. So let's try and modify it, but don't let somebody, if you're getting the same answer as everybody else and you're having to do it the way that makes you feel comfortable, you do it that way. Okay? And shame on the teacher that tells you not to. Last one of this section. Okay. Do I have anything right now that is outside of the radical? I have 2 and 5. What happens to 2 and 5? They multiply. Okay, so I feel pretty good about that. Is everyone still okay with that? So now let's break down things. I know that 8 is the same thing as 2 times 4, which is the same thing as 2 times 2 times 2. X, 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 X. Then I have another 2. X, X, X. Hey, why do you think I do it this way? Huh? Okay, why else do I do it this way? Yeah.
So make sure everything is like lined up for so you don't make a mistake.
Okay, why else do I do it this way? Because what? You say it. Why do I do it this way? What's that? Because I can? You guys want to know why I do it this way? This is how my mind sees it. Okay? This is how I see problems. Okay? I see problems, I break problems down, and then I reorganize the problem. I can't go and put this all together in my head. My brain doesn't work that way. But I see it this way, realizing that, oh, I have, for this portion, this is what goes with this portion, and this portion is what goes with that. My mind sees that. Is there anything wrong with my mind? You have to be sane, but I've only escaped from that, place a few times. Sorry, they wanted to cut holes in drill. No, I'm kidding. I was alive in the 80s. I hate to tell you, I was born in 1970. For real. December 30th, 1970. I expect cupcakes. We don't have school then, but I expect you guys get me cupcakes. December 30th. I'm going to be all right, ready? Here we go. So I am now going to make my brain ache a little bit, so I'm going to change the order of stuff. Okay, what comes out? So what's outside now? 20. What's now outside? 40. Perfect. What's inside? Can I just leave X inside by itself? You can. Yeah, it's going to be lonely, but it's there. I mean, X has got to be a pretty lonely letter. There's, what, like 16 words that actually start with the letter X?
No. Imagine.
Kids are going back, no, wait! What about xylophone? Okay, you got one of the words. What about Xerox? Okay, you got 2 of them. I challenge you to think of more. What about guitar? No, that doesn't start with an X.
What about Katara?
All right.
Xenon.
You guys ready? Should we do this? Hey. This is now this would be a word problem that I don't know if I would actually be home to do this in this fashion, but let's pretend that there are people. It says a 10-foot ladder is leaning against the wall. How far is the bottom of the ladder from the wall when the ladder reaches the height of 8 feet? Why?
Where did the ladder come from?
My backyard.
Where did it go?
It's still out in my
Where did it
backyard.
come
It's leaning
from?
against the tree that has the zip line that goes from my cottonwood tree to the apple tree at the bottom part of my backyard.
Okay, wait, hold up. Can I say something really funny?
Yes.
So yesterday when I was walking home, I saw like 3 people like tight roping in my neighborhood.
Oh yeah.
That's tight.
Slacklining.
I know.
That's
It's
tight.
Like slacklining?
Yeah.
Why don't you just say tight roping?
Because it's not a rope. It's a 3-inch.
Yeah, so I tried it. And
I got one of those in my backyard too. I got a cool backyard.
Do you really?
I don't know.
I'm serious.
That's
All right, let's do this problem, guys. Yeah, come on.
The zip line, I do have to take the ladder down because I live too close to the middle school that I fear that kids are going to ditch and hang out in my backyard and use the zip line. Being led by both my daughters. Yeah, we got a zip line. Come on. Let's ditch man. No. All right. So I am not this person. So when I go through and I put the ladder up against my house, if I step up a few steps going, oh, I feel uneasy, I step back down and then move it out a little bit further. Okay, I'm not the guy who's necessarily doing this type of problem, but they, for some reason, they create this word problem saying, hey, this ladder, how far is it from the wall? Far enough that you don't fall off is what most of you are probably thinking. Yeah, but mathematically it might not be the right answer, but that's where my mind goes with anytime I see this problem. And I'm not trying to make fun of it. Yeah, I am. But so you have a 10-foot long ladder, 10 foot, and it's leaning against the wall. It's only 8 feet up the side of the wall, which a lot of people are sitting there going, "How does that work?" And they call this the ground.
Whoa.
It's that solid surface under the cement. What's underneath the ground? More ground. What do you mean? All right, so we're going to call this X. X is now the ground. So you guys can be walking to 7-Eleven after class going ground, 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 ground.
I'll deal with that.
Yeah.
All right, so Pythagorean theorem will say, if I take the leg and I square it and I add it to the other leg squared, I will get the hypotenuse squared. Oh yeah, no applause, just throw money. Giddy up, x squared plus 64 equals 100. See if you can follow me. Subtracting 64 from both sides. Where'd that go? It was added, now I subtracted. Yo!
So what's the equation? Like, what do you do?
Do what? Where?
Well, I was thinking like equation. Like, what do you set up first?
Okay, so Pythagoras was a mathematician in the 6th century before Common Era. And he realized that the relationship of right triangles is the leg and the leg, which are the two of the shorter sides, squared and summed together, equals the longest side squared. Now, he didn't realize that square root took place back then, but he just realized, oh, wow, if I go this side squared and this side squared, and I add them together, it's equal to this side squared. And if I have this angle that makes a sharp turn called a right angle, that's what it works. So basically is you have A, you have B, you have C, where C represents the longest side, and Pythagoras named that longest side the hypotenuse after his dog.
Wait.
Wise and slender.
That's not slander.
Absolute slender.
That's what I was asking for.
All right. So, hey, what number squared gives me 36?
Wait, hold on. Question.
Talk to me.
How did you get 6y or 6x?
64.
Oh, that's 64.
Yeah,
You need glasses, sir.
No, it just looked like a y.
I just need to learn how to write.
I mean, like,
I can't.
yeah.
When you're not
Whoa.
No!
Whoa.
What happened?
I can project my voice.
Oh. People getting mad at each other.
IRL, mate.
All right. Now,
Right?
so again, so guys and girls, just so you're clear, at my house, I don't worry about how far the ladder is away from the house. I put the ladder up, I start climbing up and going, ooh, this feels uneasy. So then I move it out a little bit more.
We kind of eyeball things.
It's life, right? It's not, you get the, okay, it's a 31-foot ladder. You know what I've also done on a ladder? The top 2 steps say this is not a step. Well, if it's not a step, what the heck do you have a step there for? Confuse people in life. This is not a step. It sure looks like one.
It's for holding paint buckets and stuff.
No, but it looks the same. It should be like painted a different color. Maybe have nails sticking out of it or something. So, like, if you step on it, you're like, oh, it went through my foot. It must not have been a step.
Well, what if it rusts and you get tetanus and die?
But they have shots for that.
But
Well, what if you
don't
die
have
anyway?
tetanus?
Yeah, then your jaw locks together.
Pretty sure if you get
It
tetanus
rusts.
shots after you get tetanus, you will die.
That's what happens. But back in the olden days, like when you're walking along your wagon wheel and you scraped your leg, and you're like, oh, and you just brushed off the dirt, and then you got tetanus because they didn't realize that the salt vaccine actually worked really well.
The salt vaccine?
The SALT. It's an acronym for something. I don't know what the acronym is. I apologize. They also found that it works with polio. So
But
it's
they
kind
just like took salt water and
Like you won't
Yes.
be able to open your jaw.
All right.
Exactly how it works.
So now we went to the store and we bought ourselves a TV that's got a 24-inch diagonal screen. We're talking big screen here. Yeah, we're talking like the size of this.
Same.
Okay. I think your phones have a bigger screen than 24 inches down. The width of the TV is 16.
It's like a tablet. We're working. We're working.
Do any of you laugh at this? Because I think this is kind of hilarious. The person who has the iPod, or no, the iPad, excuse me, and they're walking around doing this, taking pictures.
That always amused me.
And you're like, you can put that down and you can see the real world. Rather than a little trip. She's gonna look. I'm gonna look through this whole thing.
But then,
I'm trying-
I know a bunch of people who do this at concerts, and it's really annoying.
He's right there.
What'd I do?
No, I know a bunch of people who do this at concerts or shows. With their
Yeah, with their iPad or phone.
they hold it up like this.
You know what I do when I go to a concert? I watch the concert and love it. I'm not the guy going, dude, I'm gonna record this. Put it on YouTube.
I mean, like, I went to a Foo Fighters concert and I didn't have my phone out, but somehow some guy managed to take a video of some drunk guy going on stage, like, singing with the Foo Fighters. It's hilarious.
He wasn't drunk.
I have a
No,
re-
he was drunk.
No, he wasn't.
He wasn't.
Did you read the thing?
Nah, he was just crying and he was drunk.
He was crying because he just buried his mother.
Oh.
Was his mother a Foo Fighters fan?
That
His
Takes the
mom.
ashes.
Wait, but did you see the video of the girl who went on? It was a baseball field and she ran around touching all the baseball
Yeah, I
players.
saw that.
Why?
I don't know.
Baseball players' butts.
Dude.
Like,
All right.
Go to soccer games.
So, we are going to figure this out. We're going to call this side X. We're going to make this the right angle. Ready? Here we go. Okay, because we're going to do this in our homes. X squared plus 16 squared equals 24 squared. Still with me? 16 squared is how much?
4.
4. No, 16 squared, not the square root of 16. But close. 16 squared is how much? 256. 24 squared is 576.
I already had that on my paper.
Subtract 256 from 576, we get what? Subtract, yes. I'm 320? Is that what it comes out to? So then, basically, I take the square root of both sides. What's the square root of 320 to 3 decimal places? It's less than 20.
Oh.
17, 18, 20,
It's like
17.888.
Yep.
Cool. What do you think? What time is it? Don't lie, because I'll find out when the bell rings. All right, this is what I want to do. For those of you who are here, you're gaining points. Those of you who are not here, sorry.
Can't hear you.
All right, let's go back and review a few things. Let's do this. Let's see if we can do this problem. This was so last quiz ago. So last quiz ago. Quiz ago. All right. We have negative exponents. They just keep saying harmful things, so they're negative. What do we do? Talk to me.
Okay, so you get that bottom
Get that.
negative x3, move it to the top with that lonely x2 to make it a beautiful x5. And then you do have to switch the other y's. So the negative 5 is going to go on the top, and the negative 3 is going to go into the bottom to make it positive. And then, okay, I'm stumped.
Okay. So I think what he had said was, is everyone okay with this guy moving up and joining that guy? Then the y's, they flip-flop. They switch spots. Okay, that's what goes with the y's. Now we have the game of tug of war taking place. Who's going to win, the top or the bottom? Top by how many? 2. Okay. Oh, I have z by itself and I have z to the 5th on bottom. So how many z's are on top? 1. Tug of war, who wins, top or bottom?
Bottom.
By how many? 4. Is the problem done? As far as the letters go. What about the numbers? They simplify. Tug of war, they reduce. What goes into both? Oh, good. Yes, right. So I get 9x to the 5th, y squared, over 8z to the 4th. See it? All right, I want you to try this one. See how you do. See how you do. Make fun of your neighbor if they get it wrong. Make them feel bad. 20. All right. Ooh, try that one. Try that one. See how you do. Huh? If you want to walk up the board, I don't have any markers. Oh, there's one in the back. You got some? All right, so does the 20 over 25 reduce? And if so, what does it reduce to? Yo, 4 over 5. I like it. Okay, what do we know about the x's? Talk to me. Yeah, so what is it on top or bottom? Top. So I have x to the 8 on top. What about the y?
You move the negative y to the top.
Okay, is it going to reduce with anybody?
No.
No.
It's the only y.
It's the only y, so that's moving on up.
The
Sweet.
only last
Z's tugging. Who's winning? Bottom by how many?
3.
Yeah. If you got it right, hypothetical high five. If you didn't get it right, I'm just kidding. If you didn't get it right, where's your question on it?
Oh my god.
I got it right, but I still have a question.
Talk to me.
How do you get the negatives into a positive when you mix them up?
Science.
Oh.
No.
Magic.
It has to do with something called the reciprocal identity. The reciprocal identity basically means that by flipping something over, it has to have, in order to show that it has moved spots or flipped over, it has to be raised to a negative exponent of some sort. That's the short answer. I have to ask another math teacher to get a better answer than that. I'll ask for tomorrow. Good call. I will. I've only been here for 2 years. They might make fun of me if I ask them, but that's okay. All right. We got time for one more. All right. if I had 1.5 times 10 to the negative 3, and that was over 6 times 10 to the negative 8, I am going to treat this problem as like this. I'm going to treat it like that. Somebody help me out. What is 1.5 divided by 6? Give me up to 3 decimals. 1.5 divided by 6. 1.5 divided by 6. 1.5 divided by 6.
Oh, alright.
1.5 divided by 6.
0.25.
0.25, I like it. So eventually I need 0.25 to look at to be 2.5, but we'll get there in a sec. Okay, these are both negative exponents, so they're going to flip-flop. Doing this. Still with me?
Yeah.
Tug of war, who wins? Top or bottom? By how many? 5. The 5th. We still okay?
Yeah.
Now, I need to move this decimal to here. So that means, like right now, this would mean move the decimal 5 spots. If I already move it over 1 spot, how many spots more would I have to move over? 4. Okay? And I think we'll work more with this later, but I plan on helping you guys out on that last quiz because some of you did not as